Okay, so let's have a look at this. It goes express r sine x plus 12 cos x in the form r sine x plus theta. We'll deal with the second bit in a second. Let's just deal with this. Now, first of all, you say 5, I've changed the, you can see that bit, 5 sine x plus 12 cos x is identical, can be put in this form. Now I'm going to expand this using our additional formula. So r, if I expand this, I'll get sine x cos theta plus sine theta cos x. If they're equivalent, then all the sines will match up with all the sines on this side, all the cosines will match up with all the cosines on this side. So if I then go and write 5 sine x, that will be identical to r. I'm going to expand this out so you know everything gets times by r, so you get r sine x cos theta. I'm going to do the same thing here. I'm going to get 12 cos x is identical to, all the coses are going to be identical to all the coses on this side, which is r sine theta cos x. Now what I'm going to do is I'm going to cancel out the sines, so I know that 5 is equal to r cos theta, and on this side I'm going to cancel all the coses, x is out, and I'm going to get 12 equals r sine theta. Now once I've got it in this stage, I can start working out what r is and what theta is. Now you could see it, what I have told you before, you could put this in a right angle triangle and note that this is theta, and remember that this is the right angle, this is called r, the hypotenuse is the r. This is opposite side. The opposite side is always called sine, r sine theta, and the adjacent side is always called r cos theta. Okay, because that squared plus that squared equals r squared. Now, what we've been told is that this is sine r sine theta is 12, and we've been told that r cos theta is 5. So r squared is the same as 12 squared plus 5 squared, which is going to be 144 plus 25, and the root of that, well, I'm going to root it, so r will equal root of 169, which is 13. So we got that. Now, to get tan, you could do two things. You could just do sine over r sine theta over r cos theta, which is basically that's how you're going to get it. It's basically if I do r sine theta over r cos theta, now that is 12 over r cos theta is 5. Now the r's will cancel, and sine theta over cos theta is tan theta, which is 12 fifths, and then theta is the same as tan inverse of 12 over 5, so theta will give me, now it is in degrees, I'm going to leave it in degrees, tan inverse brackets 12 over 5, you should get, so one decimal place, I get 67.4 to 3 single figures. Now what that tells me is that these two functions, I can combine them and make that equivalent to, that is equivalent to 13r, which is 13 sine x, and theta is plus 67.4. So basically that can be replaced by that. They are equivalent. They are exactly the same. Okay, identical. Now, trying to do something here without losing. No, it's not going to allow me. Okay. Now I'm going to clear all this because I need the space. Wait there. Let me just read the second part before I clear it up. It goes here. Hence, give details of two successive transformations that transform y equals sine x into the graph y equals 5 sine x, 12 cos x. Actually, I'm not going to delete it. I can just add that here, that part, because it's straightforward. It's told you, what do you do to this graph to make it go to there? Well, that graph to go to there, that is the same as this, and this is the same as this one. Okay? So the successive transformations, what you would do is, you could say that you stretch. First of all, you could say number one, stretch parallel to y-axis by scale factor equals 13. So you stretch this by 13. And then the second transformation that you would do is you would then translate by, now this is in the bracket, this is going, when you plus it's going backwards, so you're translating by minus 67.4 degrees and 0 in the y-axis. Okay, so those are your two successive transformations. You're doing a stretch in the parallel to the y-axis, and then you're doing a translation by vector minus 67.4 degrees and 0.